Good morning, my chemistry disciples. Lecture number 6, Organic Reactions. This is the final video lecture for the organic unit, and I do hope it will be much shorter than last video lecture, but we do have 7 reactions we have to get through. So when we're done with this video, we need to be able to recognize and categorize the 7 basic reactions. And basically what we really need to know is there are 7 major reactions that we need to be able to identify by either the properties of the reactions or the reactants in the products, especially the reactants in the products. What's going in, what's coming out is going to separate our different reactions. Now, there's going to be a lot for you to write. I'm going to try and go through this again fast. You're going to have to go over this many times. We're going to have to do a lot of practice so you can pull these out. The notes will be a one-time shot to lay a groundwork, okay? First one, favorite one, combustion reaction. Okay, a hydrocarbon, being an alkane, an ene, or an ine, ready? Single bond, double bond, triple bond, is burned in the presence of oxygen. I will always get water and carbon dioxide as a product. So I'm going to start with that. I have to see oxygen, I have to see carbon dioxide, and I have to see water. When I see that, it's a combustion reaction, and then usually right there you're going to find some sort of an alkane of some sort. Okay, so these are the keys right here. Oxygen is a reactant, carbon dioxide and water as my products, and you will see when I do the whoosh bottle that that is the case. So here it is out in word format. An alkane could be an alkene or an alkyne combined with oxygen, which is always diatomic, is going to form carbon dioxide and specifically water. Okay, now a substitution reaction is just like what it sounds like. I'm going to substitute a hydrogen for something else. Okay, now what is important here is that there's a saturated alkane. It's got to be saturated or we're going to find out it's the next reaction, which is addition. It's a substitution. So what's going to happen is a hydrogen and a chlorine are going to swap. They're going to substitute. Okay, so I'm going to start with an alkane. I'm going to have some sort of a diatomic element, usually a halide, and it's going to form a functional group. So this would be, in this case, a chlorocarbon. And its product just happens to be an acid, but that's not necessarily always going to be the case. But most of the times it is, because see this H. So yeah, I guess it is always going to be an acid. It's going to be HCl, HBr, right? They're all acids. So that's what happens here. So the H and the Cl swap, and then the Cl goes here, and the H is here, and there we go. So that's called a substitution reaction. There's a double swap. It's kind of like our old double replacement reactions. Okay, there's 2 things changing, so that's a substitution. Now in an addition reaction, we're going to specifically see this unsaturated thing going on. There's got to be an alkane or an alkene or an alkyne. Okay, I must have this double or triple bond so that I'm unsaturated. Okay, and then now I'm going to take this chlorine off and just pop it on once I break that bond. So there's no swap going on. It's just simply an addition. And what's beautiful is how I can add both in. Okay, so let me show you what the notes look like. I take this alkene and my diatomic chlorine, and now I make one big molecule. I just add it on. So I have an alkene or an alkyne. I take a halogen that's diatomic, be it bromine or chlorine or fluorine, and I make this halocarbon here. Okay, so that is what we call an addition reaction. Esterification. This is going to be a tough one to remember. I'm sorry, not necessarily to remember, but to say. Esterification is what it says. And I create an ester. So that's what's nice about this. It's right in there. Esterification is making an ester. What you need to be able to tell me or help figure out is that the ester is either on the product side, or you see that I take an alcohol and an acid, and then it does a dehydration, which means it removes or produces water. Okay, so that's what that means. So I'm going to start with an alcohol. There's a Cu. I'm going to have an acid, which is I'm sorry, I got them backwards. This is the acid, the Cu. This is the alcohol with the OH. Notice they both have OH, so they can be tricky. I'm going to form the ester and water. And this water, whenever I form water, that's called a dehydration. I'm taking water out of the reactants. So it's called a dehydration. Just like if I took water out of you or me, we would be dehydrated. Okay? I'm going to have my organic acid plus an alcohol forms an ester and a water. The parts you need to memorize are these kind of things. These words is what we memorize. Then we apply them into, real world type chemistry problems. So you got to memorize the words and then be able to put them into chemical formula. Okay? And here's another example right here. We're moving on to saponification. Saponification almost sounds like soap, and that's exactly what it is. I'm going to start with an ester. I'm going to hit it with a base like lye. I'm going to produce alcohol and soap. So let's show it. I have an ester plus a base goes to alcohol and soap. And here is a long, dragged out ester where the base is producing an alcohol and a soap. And we don't have any other real way to show that there's a soap. So what I'm really looking for to know that it's an saponification is when I see the base and the ester over here. When I see that ester is a reactant with a base, that's how I memorize that I'm making a soap. I can't just look at this chemically and tell that that's a soap necessarily, okay? There's no classification for soaps as far as our organic compounds. We definitely use table R with our functional groups to identify these, and their reaction is very complicated looking, mostly because this triglyceride ester is huge, right? And it's really ugly looking as far as there's a lot of stuff. 2 more to go and we're done. Fermentation. Fermentation makes alcohol. That's how we make wine. We ferment it. So we take some grape or apple juice, let it sit in the fridge too long, it gets hard, is what we say, is a common word, but what's really happening is it's fermenting. Okay, so I produce an alcohol and carbon dioxide. Those are the 2 things I'm looking for. Also, I'm breaking down a sugar. And so, hey, grape juice, got grape, it's got sugar in there from the grapes. Apple juice has sugar in it from the grapes. So that's where we get that stuff. So I'm going to end up with a carbon dioxide and some form of a regular alcohol. I'm going to take sugar with an enzyme to make that happen. Okay, and then let me put it out in writing format. So fermentation is specifically making alcohol with some bubbles, carbon dioxide. So that's how we got to remember that. As far as fermentation, I'm looking for an alcohol being produced with carbon dioxide. Okay. Polymerization. This is a Kodak thing. Sorry you don't want to hear about Kodak, but basically it's taking small carbon molecules and just linking them together. We call them growing them. And Kodak's actually very, very good at making polymers by controlling the situation present at the reaction time. If I get it to a certain temperature, the reaction is going to start. If I hold it for a certain amount of time, the reaction is going to be at a certain size. I'm going to get this molecule larger. And they've gotten really, really good at these. So let's go down and do what we're looking for on this. I'm going to take small molecules, monomers, and join them together. Mono means one, poly means many. So I'm going to make many. So I have an ethene and an ethene. These are my 2 small molecules. Okay. And I'm going to form them into polythene. polythene, because now there's many things, I guess. We're going to see a condensation polymerization. That means I'm going to remove water. So I'm going to take the OH of one and the H of another. So here's the H, OH here, and this H. When I form those together, that's going to form water. And I'm going to be able to hook up. Let me do a different color. This O is going to hook onto that C. Okay, and there it is. Here's the O hooking onto that C. And that's my condensation polymerization. I don't think that polymerization is very common as far as testable questions. We might see something like a polymerization, but notice I didn't have anything on the list that it's this plus this equals this plus this. There's no recipe for a polymerization. It's just growing. So think of a chia pet. It's just growing like crazy, okay? So I'm going to take something small and I'm going to link on more and more and more of it. And that's called a polymerization. We have now gone through all 7 organic reactions. I did make a quiz, and it is not quiz 2. It is, I believe, going to be quiz 3 for organic reactions. Okay, it's going to be quiz number 3, and you can do the last 2 pages of the practice packet, and we're all set. Mr. Milks, you got it under 25 minutes. Thank you so much. I will see you guys tomorrow in class.